To find our inverse, the first thing we need to do is first make sure it's a square matrix. Check. All right, the next thing is to do is find the determinant. Our determinant is going to be our angled ones multiplied and then subtracted. So we're going to have 2 times 1 minus that negative 3 times 1. Well, that's going to be 2. It's going to end up being plus 3, so that's going to be a 5. All right, then our inverse, what we're going to do is we're going to swap the top left and bottom right numbers. So that 1 and 2 are going to switch places. So we're going to have 1 up here, 2 down here. And then we're going to switch the signs in front of the other 2. So that's going to be a positive 3 and a negative 1. Then we're going to put them all over that determinant. So it'll be 1 over 5. It'll be 3 over 5. It'll be 2 over 5. And it'll be negative 1 over 5. So in fact, our correct answer should have been C. C is our correct answer. That being said, do we have any questions from the homework? Yeah, Fritz. 21. Um, 21 you can't do. They can't be inverses because they aren't squared. They have to be square matrices to have an inverse. So they can't actually be inverses of each other because neither one is square. So remember that. In order for, anytime I say inverses, you should look for square. If they're not square matrices, the answer is can't do it. All right, that's why that one is you cannot do that one. Other questions? Yeah? 7. 7. Do you have a specific question or just you came up with different numbers?
I came up with different numbers.
Okay. So we are multiplying matrix negative 2, negative 3, 3, 4. And we're multiplying that by 4, 3, negative 3, and negative 2. First of all, we have to check to make sure we can multiply them to begin with. This is a 2 by 2. This is a 2 by 2. I check these inside ones. If those are equal, then we are good. We can go ahead and do that multiplication. All right, to do that multiplication, we have to do row times column. So that's going to be that negative 2, negative 3, and we're going to multiply it by that column, and then we'll follow that up by multiplying by that column. All right, we are going to end up with, on the top, we're going to have negative 2 times 4, plus negative 3 times that negative 3. I don't know if I can fit all that in there, so let's just drop this down to the row below. All right, then we're going to have negative 2 times 3, and plus negative 3 times a negative 2. Our bottom row should be 3 times 4, plus 4 times a negative 3. And then we should have 3 times 3, plus 3 times negative 2. Do those numbers look like the numbers you have so far?
I think I multiplied the last one by negative 3.
Oh, okay.
I got a 0 for that.
For this one here?
No, for the one on the right. Yeah.
That one? Oh, okay. Yep. It should be 9. Oh, it should have been 4 times negative 2. It should have been 4 times negative 2. Yeah, it should have been 3 times 3 plus 4 times negative 2, because that would give us our 1. So that would be negative 2 times is 8, plus 9 is 1. This one is 0. 3 times 4 is 12. That would be 0, and this one would be 1. So yeah, the bottom right one should be 3 times 3 plus 4 times negative 2, right?
Yeah.
Okay. Other questions? Okay, today we're going to learn another method to solving a system of equation, but this time we're going to use inverses. So we're going to use inverses to solve it. So the big trick here is we're still using matrices, but if you remember with Gaussian, we use those augmented matrices. these we're going to use inverse matrices. So you have to know the difference. When I ask you to do Gaussian, you're going to use an augmented. When you use inverses, you're just going to use inverses. So we have a system. It is ax plus by equals e, and cx plus dy equals f. There's a way to represent this without using an augmented matrix, and that is to leave it as kind of an equal sign with matrices. And what we're going to do is we're going to have one matrix that's A, B, C, D. We're going to have a 2 by 1 matrix that's X and Y. And finally, on the other side, we're going to have E and F. These are saying the exact same thing, because if we do a little scratch work off to the side, if I asked you to do A, B, C, D, and I told you to multiply that by X over Y, you can, because it's a 2 by 2 times 2 by 1. Well, that's going to equal A times X, which would be AX, and B times Y plus BY. And we move to the next row, and we would have CX plus dy. So I am just kind of reverse engineering that. I know if I multiply this out, I get ax plus by. I'm just going the other direction and writing it as a matrix. We did this in our homework. I set one side up where you had to do the multiplication, and then you can come up with the two columns being the same. So we're just kind of going backwards in this. And when I use the letter M, that is the matrix. That is the matrix we're focusing on. That is our A, B, C, D. Now, when I use the letter M to the negative first, that means our inverse. So that would be our A, B, C, D, but the inverse of it. This is my inverse function. It's hard to display it without that because we don't actually have the inverse. So those are the terms I'm going to be using. Well, the solution for A, B, C, D is X over Y. Well, whenever we solve an equation, we try to get all our variables on one side, and we try to get everything else on the other side. So what I want to do is I want to get this A, B, C, D, and I want to somehow get it to this side. But we're not going to use division because dividing matrices just is not a viable option here. So instead, we're going to take the inverse of it. We are going to take the inverse of A, B, C, D, and that's going to eliminate our A, B, C, D. So let's say I multiply the left-hand side by the inverse function. If I multiply the left-hand side by the inverse function, a matrix times its inverse becomes the identity matrix. It becomes the identity matrix. So if I take A, B, C, D, I find its inverse, multiply it to this side, I am left with the identity matrix of that 1, 0, 0, 1. When you multiply this side by the identity matrix, you're just left with X over Y. So it's just like if I have 3x and I multiply the left-hand side by 1/3. That leaves you with 1x. That's the exact same thing that's happening. I am multiplying by its inverse, and realistically, I'm left with just 1 times this. So I'm just left with x over y. Now, we aren't allowed to just multiply one side by a number. To keep it balanced, we have to multiply the other side by the same exact thing. Now, the problem with matrices are you only can multiply like a 2 by 2 by a 2 by 1. If you switch that order, a 2 by 1 does not multiply into a 2 by 2. So you have to do this in a very specific manner. You have to put the inverse in front. All right? We can't do E over F times the inverse. The inverse has to be in front. So when I multiply the left-hand side by my inverse, I have to multiply the right-hand side by that inverse, but it has to be in front. Because right now this is a 2 by 2. And this is a 2 by 1, so you can do that multiplication. If you're ever doing this method and your calculator or something spits out that you did it wrong, or you can't do that multiplication, you probably put it in the wrong place. You probably put it after. Because we're really used to putting something in and just multiplying it by something. So this has to go in front. That is important. It is important. It's unsolvable if you don't. Now when I multiply it by this matrix, we're going to end up with two new numbers, j and k. And at the end of the day, we're just going to have x over y equals j over k, which means x would equal that j value, and y would equal that k value. I put a little note over to the side just to shortcut this, and we'll shortcut the next one too. We'll do an example, and then we'll show you how, because it's going to be a whole bunch of steps that you won't have to do. Thus, we're just going to have, in this problem, x over y is in fact going to equal the inverse of a, b, c, d times that e and f. So realistically, this is all we're trying to do. We're trying to find the inverse of this a, b, c, d, and we're trying to multiply it to the right-hand side because we already know what happens on the left-hand side. It turns to the identity. All right, so this is the bulk of the work that you need to do. Find an inverse and multiply it by your right-hand side. Now, in the next example, we're going to go through all the steps. But in the homework, I don't expect you to show me you're multiplying a matrix and it cancels out to the identity, because it's a whole bunch of writing stuff down that you should kind of understand why we're doing it. So this example, we're going to do the whole thing. And then I'll kind of underneath, you can see that line down there on the very bottom. I'm going to show you kind of a shortcut of what I expect to see on your thing. All right, so we're supposed to solve using inverses. The first thing you're going to do is you're going to set it up as matrices. Note we aren't using augmented matrices. You have to be very clear on the test on what you're doing, because there will be a calculator section. And I'll show you tomorrow how I want you to show work on a calculator section. But you have to be very clear that you're not using Gaussian elimination by accident. So we're going to set up our equations as matrices. That means we are going to take that 3, 2, 2, and 1, and we're going to turn that into a 2 by 2 matrix. So we have 3, 2, 2, 1. And then we'll have x and y. And that's going to equal that 4 and negative 3. The order you put the x and y is important. Yeah?
Should it be negative 2?
It should be a negative 2, yes. That's why I looked up real quick. I'm like, there must be a mistake. The x and y order matter. It will be the order that they come in here. So if I switch these, if I would go 3y minus 2x, you would have y on top and x on the bottom. And this can actually apply to a 3 by 3 matrix. So we could have a z in here. Make sure they are in a proper order. So if we, from left to right, we have x, y, z. The top to the bottom would be x, y, z. So order of your variables matters. All right, so right now we have our equation set up. Remember, I'm just putting this as matrices. I didn't change anything because 3 times x gives me 3x. Negative 2 times y gives me that 2y. So the equation's still there. All right, our next step is we're supposed to find the inverse of the matrix with the coefficients. This is my matrix with coefficients. In other words, this is my coefficient matrix. So we need to find the inverse of 3, negative 2, 2, and 1. I don't think I did anything extra on that step. No. So we need to find the d value. The d value is going to be our top left times our bottom right. 3 times 1 minus our top right times our bottom left. So that'll be negative 2 times 2. So our d is going to equal 3. Well, that's negative 2 times 2, which becomes a negative 4. So 3 minus a negative 4, we're actually adding, and we should come up with 7. So that means if I have 3, negative 2, 2, 1, the inverse of that is going to equal. We switch our top left and bottom right values. We actually have a 1 in the top left. So that's going to be 1 over 7. The bottom right is going to become a 3 over 7. Top right, we change the sign from negative 2 to a positive 2. So we'll have 2 over 7. Bottom left, we change the sign from a positive to a negative. So I'll have negative 2 over 7. That is now my inverse. This is basically the only time I'm going to actually make you show me that you multiplied both sides by it. It's in your notes so you can see why you did it. Like I said, down below, I'll kind of show you the shortcut of what I'm looking for to show that you did the work. So this says multiply each side by its inverse. So our left-hand side, did I leave enough room? Our left-hand side, we are going to have 1 over 7. That says a 2. That says a 7. There we go. 2 over 7, negative 2 over 7, and 3 over 7. We're going to multiply that by the left-hand side. So that's at 3, negative 2, 2, and 1. And then we have our x and y. And that's going to equal, now here's where it gets important. Put your inverse in front of that 4 and negative 3. So you should have some kind of note in you that says put this in front of it. So we're going to put the inverse in front. So this is going to be 1 over 7, 2 over 7, negative 2 over 7, 3 over 7. And we're going to multiply that by, bless you, over our 4, negative 3. And a reminder, we do that because this is a 2 by 2. This is a 2 by 1. So we can do the multiplication. If you'd flip that and put on the back end, you'd have a 2 by 1 being multiplied by a 2 by 2, which you cannot do. Has to go in front. I'm going to keep telling you that over and over and over because that's the biggest mistake I see is people putting it in after and they go, oh, you can't do it. I solved it. All right, we look at the very left-hand side. This is going to cancel out because it's going to turn into the identity. This is going to become the identity function, which would be 1, 0, 0, 1. And when I multiply 1, 0, 0, 1 by x over y, I'm just left with x, y. I'm just left with that matrix. The identity always leaves the matrix unchanged. So in fact, I'm turning this into 1. 1 times x over y is just still x over y. So our left-hand side is just x over y. Excuse me. So let's leave a little room here. So x over y is going to equal this multiplication. We're going to multiply row times column. So we're going to do 4 times 1 over 7, which in our top is going to be 4 over 7, plus 2 over 7 times a negative 3, which would be a negative 6 over 7. On our bottom, we'll have negative 2 over 7 times 4, which would be a negative 8 over 7. Plus that 3 over 7 times a negative 3. So plus a negative 9 over 7, which is just going to equal 4 minus 6 is negative 2 over 7. And then negative 8, excuse me, is going to be a negative 17 over 7. So since we have x, y matrix equals negative 2 over 7, negative 17 over 7, we can end up just saying, well, x equals a negative 2 over 7, and y equals a negative 17 over 7. Questions at any of those steps? Like, does something just not make sense why I did it? Or why stuff canceled out? Yeah, Liv.
Like, you're talking about how you like X, Y, and Z,
Mm-hmm.
but how would you find the inverse? Because only...
You'd use a calculator.
Okay.
Yes. So there is a way to, if we have a 3 by 3 matrix, and this is completely off topic because I don't feel like spending a ton of time on this, so that's why I kind of cut it from our curriculum. Anytime you have a big one anyway, you're going to have a calculator on any section. So let's say we have 2, 4, 7, 3, 6, 2, 1, 7, 7. And I told you to find the inverse. What you end up actually doing is you end up reducing it to a bunch of 2 by 2 matrices. Can you kind of see all those 2 by 2s I did? So by hand, what you do is you reduce it to these 2 by 2s. You find all of those inverses, and you kind of put it together as this Frankenstein monster that comes into the inverse of that. So it's a whole bunch of work when your calculator is just boop. All right, and any major test that's going to have you define the inverse of that, they're going to let you use a calculator on. So I figure as long as you know what an inverse is, and that's why we do the 2 by 2, you can do it by hand. You know what it is. You know how it functions. That's all I'm looking for. Anything bigger, we'll just use our calculator. At least you know what's going on, kind of. All right, that being said, any other questions on any of these steps? Because you kind of have to understand it in order for you to not have to just memorize this pattern and actually know what's going on. All right, then if you notice, there's like a little gap. I put a little line here. And that line is for, you can do all those steps up there. You can show me you're multiplying both sides. But in effect, this is all we're really looking for on the homework, or the work I'm actually looking for. So let's say I give you ax plus by equals e, and then we have cx plus dy equals f. A good idea is to write that first as a matrix form. So we'd write a, b, c, d times x, y equals e, f. It's always a good idea to at least know what you're doing. But the major work I'm looking for is I'm looking for that at some point you have x, y equals a, b, c, d. Well, that would be the inverse. And then e, f. So when you get a problem like this, always a good idea to write this, find your inverse, and just multiply it by your right-hand side, already realizing that this turns into the identity. Otherwise, you're taking up a whole bunch of room. And for example, an example of kind of how you're going to read my answer key, and most of the problems are like this, so we're going to see kind of the first problem. What I did is I knew what it had to be. I knew it had to be a, b, c, d times our x, y equals. So I just said my matrix, my major matrix with coefficients is 1, 6, 1, 9. I found the inverse of it. I took the inverse and multiplied by the negative 3, 6. I came up with that value, and I realized that x over y equals that negative 1. So that's how my answer key is. You probably should, to the right of this, actually write out your full thing so you get in the habit of being able to go 1. This isn't for you guys to copy down. You should probably have something that's like this. So you get in the habit of being able to see what it looks like. My answer key doesn't have it on there, but you should, so you get in the habit of being able to write it. Then you can reverse engineer. You know what's going on better than someone that just finds the inverse and just does the math. Yeah?
So when you find the answer, or like, would you prefer having it in?
I don't care. I really don't care. I just, sometimes I get lazy and I just do the 3, 1, negative 1. It's the same answer as x equals 3, y equals negative 1. It really is what mood I'm in at how I write the answer. But yes, either way, we'll be fine. All right, the rest of the time is yours to work.